Hey everyone, welcome to Math 106, section 4.4 percent problems. We're going to be working on two different types of percent problems today. In the first one, we're going to take a sentence and directly translate that into a mathematical equation using keywords. So whenever we encounter these keywords, they'll be directly translated into mathematical symbols. So first example, what is 10% of 50? So we're going to look at this sentence and first identify the keywords. Right? What? That's the question word. And that translates into a variable. So what turns into some variable? I'm going to use n. The word is translates into the equal sign. And that's very common in mathematics to use is for equals. Now if you look at step 2, we're going to convert any percent into a decimal. So we'll take this 10% down here and turn it into 0.1. Right, we're moving that decimal 2 to the left, as we saw in the last lesson, and it turns into 0.1. And then of is multiplication, so multiply here, and then the 50 comes down. So that sentence translates into n equals 0.1 times 50. All right, now, if the variable is by itself, evaluate the other side of the equation. So step 3, the variable is already by itself. We're going to evaluate this side, 0.1 times 50, and that gives us 5. So n is 5. So 5 is 10% of 50. Your turn, number 1. Remember, I'm not going to pause. I'm just going to keep on going. So pause the video, work on the your turns, and then come on back. All right, what is? What is n? Is the equal sign. 17%. Moving that decimal 2 to the left gives us 0.17. Of is multiplication, and 23. So 0.17 times 23 gives us 3.91. In example 2, we have a little different configuration here. We'll start with a percent, 21%. 2 to the left gives us 0.21. Of is multiplication. What is the variable? Is the equal sign, and 59 comes straight down. All right, now we've got to move on to step 4. The variable is multiplied by a number. So we'll divide both sides of the equation by the number that the variable is multiplied by. So divide both sides by 0.21. Those will cancel, leaving just n on the left side. Make sure whatever you do to one side of the equation, we do the exact same thing to the other side. So 59 divided by 0.21 is 281. So 21% of 281 is 59. Your turn, number 2. 35%. Move it 2 to the left, we get 0.35. Of is multiplication. What's the variable? Is the equal sign, 6. All right, now divide both sides by 0.35. One mistake I occasionally see is people dividing both sides of the equation by 6. That doesn't do us any good. We want to divide by the number multiplied by the variable so that that cancels. Leaving n on the left. And 6 divided by 0.35 is 17.1. Next up, now we're going to find a missing percent. What percent of 60 is 15? So what percent of its multiplication? I usually use P for percent. So P times 60 is the equal sign, and 15 comes down. All right, now we're going to divide both sides by the number being multiplied by the variable. So divide by 60, and P equals 0.25. Now the question asks for a percent, so we need to convert this to a percent. So we'll take that decimal, move it 2 to the right, and get 25%. So 25% of 60 is 15. Your turn, number 3. What percent of 80 is 12? All right, what percent? It's P of is multiplication. 80 is the equal sign, and 12. Divide both sides by 80, and we get P equals 0.15. Take the decimal 2 to the right, and we get 15%. Now, example 4, we're still looking for a percent here. But the sentence is in a little different format. 78 is what percent of 95? So you may see it phrased like this. 78 is the equal sign. What percent is P? Of is multiplication. And 95. Divide both sides by 95. And we get P equals 0.82. Which is 82%. All right, 40 is what percent of 200? 40 is the equal sign. What percent's P? Of is multiplication, and 200 on the end. Divide both sides by the number being multiplied by the variable, and we get P equals 0.2. Move the decimal 2 to the right, we get 20%. Now in each of these problems, we had a base, and we had a part, and we had a percent. 78 is what percent of 95? 95 is the whole amount, that's the base. And then 78 is a part of 95. So we got part, percent, and base. Think of the base as being the whole. Now we're going to look at some application problems, and we'll translate those by identifying the percent, the base, and the part. So the percent equation is the part equals the base times the rate. So let's say the base is 100, and the rate, we want 30% of 100, we would take 100 and multiply by 30% and get 30. Now the part doesn't have to be smaller than the base. Sometimes we could have a rate that's over 100%, and that'll give us a bigger part, but usually the part's going to be smaller than the base. So we'll be using the PBR equation, and we're going to follow this procedure. Identify the two known quantities and the one unknown quantity. Right? One of these variables is going to remain a variable. The other two variables, we're going to have numbers plugged in for them, and then we'll solve for the variable. We're going to place the quantities in the appropriate places and then solve. So for example, number 5, the sales tax on a new guitar, which cost $500, is 6%. How much sales tax is paid? Well, $500 is the entire price of the guitar. That's the base. So our base is 500, so we'll plug in 500 for B. We're also given, and this is the easiest one to see, if you're given a percent, you know that's the rate. So 6%, we're going to translate that into a decimal and then plug it in. So the part is 500 times 0.06. Multiply that out, and we get 30. So the sales tax on that guitar is $30. Which makes sense. Whenever you get an answer, let's see if it makes common sense. Well, the sales tax is going to be less than the price of the guitar. You're not going to pay more in sales tax. So that makes sense. All right, your turn, number 5. A player in the Detroit Pistons made 24% of the three-point attempts during the season. If the player attempted 75 three-pointers in the season, how many were made? The total number of attempts is 75. So that's the base. That's the total amount. So that goes in for B. And the player made 24%. So 24% is 0.24. So we'll multiply 75 by 0.24 and get 18. So the player made 18 three-pointers. Example 6, we have an unknown percent. So in a basketball game, a player made 13 of 24 shots. What percent of shots did the player make? So we'll start with the equation, PBR. The total number of shots is 24, so that's the base. We don't know the rate, that's going to remain a variable. And the part is 13. 13 were made out of 24. All right, now to solve for R, divide both sides by 24. And that gives us 0.542. And then converting that to a percent, move the decimal to the right, and we get 54.2%. So the player made 54.2% of shots. Your turn, number 6. A manufacturing facility produced clothing. The quality control manager has been keeping track of the production of a specific brand of blouses. The manager found that of 15,600 blouses produced, 624 had defective stitching. What percentage of blouses had defective stitching? The total number of blouses produced, that's going to be the base, and it's 15,600. We're looking for a percentage, so that's the rate. So keep that as R, and we found that 624 had defective stitching, so that's the part of the whole. Divide both sides by 15,600. And that gives us an R of 0.04. So that means R is, with the decimal to the right, we get 4%. So 4% of blouses had defective stitching. Example 7. In a recent survey, it was found that 1,524 people in a city lived in apartment buildings, and that is 12% of the city's population. How many people live in a city? So which one's going to be the base? Is it the number of people who live in apartment buildings, or the number of people who live in the entire city? Well, the base is clearly all the people in the city. So we're solving for the base. And the part is the people living in apartment buildings. So 1,524 equals the base times 12%. .12 is 12%. So we're doing 0.12 times B. Divide both sides by 0.12, and we get B equals 12,700. So the population of the city is 12,700 people. Your turn, number 7. An employee of a hospital is reading her statement for a pay period and noticed that $327.85 was deducted for taxes, which is 17% of her total salary. What is her total salary for the pay period? So is $327.85 the part or the whole? Well, I hope it's the part. Otherwise, she's not making much. So $327.85 goes into the part. Our total salary is the base, so that's going to stay a variable. And then we got 17%. And 17% is 0.17, so you got 0.17b on the right. Divide both sides by 0.17, and b equals $1,920.53. Alright, so up till now, each of the exercises, I've told you which type it is and what the unknown is we're looking for. Now we've got some mixed exercises, some different types there. So see if we can identify what the missing quantity is and what we're solving for, and then set up your equation to solve. Number 1, the homeowner has a water softener installed and the bill is $1,550, of which $300 is for installation labor. What percentage of the bill is for installation? Okay, this is the easiest type to see what we're solving for, because it asks right in the question what percentage. So the percentage is going to be remain a variable. And that's what we're solving for. All right, now the total bill is $1,550, so that's the base. Total is the base. And the part, installation, goes on left. So $300 for part, $1,550 for the base, and we're solving for R, the rate. All right, divide by the number next to the variable. And R is 0.194. So if we take the decimal and move it 2 to the right, we get 19.4%. So the total cost of the job, 19.4% is for labor. Number 2, a college accepts 15% of all applicants. Last year, 3,758 people were accepted to the college. How many people applied? We're given a percent, 15%. And then 0.15, so that's going to go in for the rate. Now we need to determine if this number given is the part or the whole. 3,758 people were accepted. Is that the total, or is that just a part of the total? Well, a lot more people applied than were accepted. So the application, the number of applications represents the whole, and the people accepted is the part. Divide both sides by the percent, and we get B equals 3758, 3,758. So, oh no, that's the given. Oh, I'm sorry. I ran off the wrong thing there. Knew that was a little late. 25,000. Hey, everybody was accepted. Okay, 25,053 people applied to college. Number 3, a baseball team won 60% of their 50 games this season. How many games did they win? So you got the rate, 60%, and 60% as a decimal. The decimal to the right and, oh wait, to the left, and we get 0.6. So we're going to plug that in for R. Now we need to determine, is 50 the base or is it the part? Well, 50 was the total number of games they played in the entire season. So that's the base. And we're solving for the part. So 50 times 0.6 is 30. So the team won 30 games. Number 4, sales tax on a new computer is 5%, which came out to $34. How much was the computer? So is 34 the part of the whole? Well, it's definitely the part. You're not getting a new computer for $34. So 34 is going to go over here for the part. And sales tax is 5%, so 5% is 0.05, so that's going to go in for R. And B remains a variable. Divide by 0.05, and we get B equals 680. So the computer costs $680. And that is it for today. Have a great day.